Hello student, today I'll discuss about the preparation of bases. There are many methods of preparation of bases. Let's see. First, from metals. When metals reacts with oxygen, it forms metal oxide. Metal oxide, and I have told in previous videos that metal oxide or metal hydroxide both are basic in nature. That's why when metal reacts with oxygen gas, it will form basic oxide, metallic oxide. That is, it will form metal. Yeah, it will form base. So, for example, sodium when react with oxygen, it will form sodium oxide Na2O. When magnesium react with oxygen, it will form magnesium oxide. That is 2Mg plus O2, 2MgO. 4Na plus O2 implies 2Na2O. Okay, so first preparation of bases from metals. Next method is by the action of water, on reactive metals like sodium, potassium, calcium. When these reactive metals, that is sodium, potassium, calcium, reacts with water, it will form basic hydroxide, or it will form base and hydrogen gas. Okay, so when sodium react with water, it will form sodium hydroxide plus hydrogen gas. When potassium react with water, it will form potassium hydroxide, that is KOH plus hydrogen gas. That is, the balance reaction is 2K plus 2H2O implies 2KOH plus H2 gas. When calcium reacts with water, that is Ca plus 2H2O, it will form CaOH whole twice, calcium hydroxide plus water. So second method of preparation of bases is by the action of water on reactive metals. Reactive metals means sodium, potassium, calcium. Okay. And third, by the action of water on soluble metallic oxide. So the third method is by the action of water on soluble metallic oxide. For example, metallic oxides such as sodium oxide Na2O, metallic oxides such as potassium oxide K2O, calcium oxide CaO. When these soluble metallic oxides reacts with water, it will form base, that is metal hydroxides. Metal hydroxide, you know that all metal hydroxides are basic in nature. So the reactions are Na2O plus H2O implies 2NaOH, sodium hydroxide, K2O plus water 2KOH, is potassium hydroxide is also base. Calcium oxide plus water implies CaOH whole twice calcium hydroxide, which is also base. So when metal oxide reacts with water, soluble metal oxide reacts with water, it will form base or alkali. Fourth method of preparation of base is by double decomposition. And this one is important chemical reactions. Okay, you have to remember. So by double decomposition reaction, you can prepare some bases, okay, some basic hydroxides. For example, when aqueous solution of some salt like FeCl3, CuSO4, AlCl3, when aqueous solution of salt like this FeCl3, CuSO4, AlCl3 reacts with a base or alkali, it will form another basic hydroxide by double decomposition reaction and a normal salt. So when aqueous solution of some salt reacts with a base or a alkali, a new basic hydroxide or new base will produce along with a normal salt. For example, when FeCl3, ferric chloride, reacts with the alkali NaOH, that is FeCl3 plus 3NaOH, it will form FeOH whole thrice, ferric hydroxide, and precipitate of ferric hydroxide and 3NaCl. So ApCl3 plus 3NaOH implies ApOH whole thrice uh, a down arrow, okay, down-headed arrow, which means a precipitate, okay, ApOH whole thrice precipitate plus 3NaCl. Similarly, when copper sulfate CuSO4 reacts with NaOH, that is CuSO4 plus 2NaOH, it will produce copper hydroxide, precipitate of copper hydroxide, which is basic in nature, CuOH whole twice plus NO2SO4. And similarly, when AlCl3 react with ammonium hydroxide, that is NH4OH, it will produce AlOH whole thrice, aluminum hydroxide plus ammonium chloride. All these reactions are double decomposition or double displacement reaction. Okay. So by using double decomposition reaction, you can prepare some basic hydroxide. The fifth method is by the action of oxygen on metal sulfide. The scheme of this reaction is when metallic sulfide reacts with oxygen, it will produce metallic oxide and sulfur dioxide gas. So when zinc sulfide, that is ZnS, reacts with oxygen, that is O2, ZnS plus O2, it will produce ZnO plus SO2. Similarly, PBS plus oxygen, it will produce PbO plus 2SO2. You have to write the balance equation. Okay. And sixth method is decomposition of a salt. Some salts such as the metal carbonates on heating decomposes to form basic metal oxides and carbon dioxide. So metal oxide, metal oxide are basic in nature. So by decomposition of some salt, by heating, you can get some basic compound. For example, when metal carbonate on heating, it decomposes to form basic oxide and carbon dioxide. Some examples are calcium carbonate on heating, it will produce calcium oxide, that is CaO plus carbon dioxide, that is CO2 gas. Copper carbonate on heating, it will produce copper oxide plus CO2 gas. Okay. One point you have to remember here, sodium and potassium carbonate do not decompose on heating. They are stable to heat. That's why they cannot produce basic oxide and carbon dioxide on heating. Sodium carbonate, potassium carbonate do not produce basic oxide, that is sodium oxide and carbon dioxide on heating. Okay. Next, next is when this one is heating up metal carbonate to produce metal oxide and carbon dioxide. Similarly, when metal nitrate, that is MnO3, metal nitrate on heating, it decomposes to form basic oxide and nitrogen dioxide and oxygen gas. Here are three products: metal oxide, that is basic oxide, plus nitrogen gas plus oxygen gas. Some examples: heating of metal nitrate, for example, calcium nitrate on heating, it will produce calcium oxide and nitrogen dioxide and oxygen gas. Similarly, zinc nitrate, that is ZnNO3 whole twice, on heating it will produce zinc oxide, ZnO plus NO2 plus O2. You have to write in exam paper, you have to write the balance equations. Okay. So heating of calcium nitrate is, the products are calcium oxide, NO2 and O2. And the balance equation is 2CaNO3 whole twice implies 2CaO plus 4NO2 plus O2. Okay, similarly 2ZnNO3 whole twice implies 2ZnO plus 4NO2 plus O2. Okay, so on heating metal nitride, you can get metal oxide, basic oxide, and nitrogen dioxide and oxygen as side product or byproduct. Okay, here you have to remember one point, that sodium and potassium nitrate do not give metal oxide when decomposed. That is, on heating, sodium nitrate and potassium nitrate do not give metal oxide. Okay. And the last method of preparation of basic compound is from last example, the method number 7 is the preparation of ammonium hydroxide. You know that ammonium hydroxide NH4OH is basic in nature, is a weak alkali, and this one can be prepared by simply dissolving ammonia gas in water. So when ammonia react with water, that is NH3 plus water, it will form a soluble base, that is a weak alkali NH4OH, ammonium hydroxide. So these are the basic methods of preparations of bases. Now physical and chemical properties of base or alkalis. So first first physical properties of bases or alkalis. You know that alkalis are soluble bases. Okay. So first physical properties are first physical properties is bases have a sharp and bitter taste. The taste of bases are the taste of base, all bases, the taste is bitter taste, like the taste of acid, sour taste. The taste of bases is bitter and sharp. Second physical property, they change the color of indicators. Like acids, bases can also change the color of some indicators. Okay, for example, litmus indicator, name of indicator is first name of indicator and color change given, I have marked. Okay, so first litmus, in basic solution, red litmus changes into blue. The color of red litmus changes into blue in basic medium, while in acidic medium I have told that in acidic solution or acid changes blue litmus to red, but bases changes red litmus to blue. Similarly, methyl orange indicator, the color of methyl orange indicator in basic medium or in base any bases, the color change is orange to yellow. Similarly, the color change of phenolphthalein indicator is in basic medium is colorless to pink. Okay, and insoluble bases do not affect indicator. So you have to remember that name of indicator and their color change in basic medium. Okay. The third physical property is they are soapy substances. Bases are soapy substances, that is, they are slippery to touch. One point is given in the box. You can see caustic soda, that is NaOH, and caustic potash, that is KOH. These are strong alkalis. And we know that alkalis, when alkalis react with oil, it will form soap. When any alkalis react with oil, it will form soap. Since our skin contain oil in the form of fat, hence when we touch caustic soda or caustic potash, a reaction take place and soapy solution are formed. Okay, and fourth physical properties, they are strong electrolyte, and the last physical properties, they show a mild corrosive action, uh, slight burn on the skin. Okay, so these are physical properties of bases. Mainly you have to remember the color change of different indicator in basic medium and the taste of bases. Okay, now chemical properties of bases, that is chemical reactions. Some chemical reactions of bases here given, you can see. First chemical reactions, when strong alkalis reacts with carbon dioxide, that is strong alkalis absorb carbon dioxide from the air, it will form the metal carbonate and water. So strong alkali scheme of the reaction is strong alkali plus carbon dioxide, it will form carbonate, metal carbonate and water. For example, when sodium hydroxide, strong alkali, potassium hydroxide, strong alkali, these alkalis reacts with carbon dioxide, that is CO2. It will form sodium carbonate, calcium, potassium carbonate, that is Na2CO3, K2CO3, and water molecule. Okay. One example: 2NOH plus CO2, Na2 implies Na2CO3 plus water. 2KOH plus CO2 implies K2CO3 plus water. Okay, so when strong alkali reacts with carbon dioxide, it will form metal carbonate and water. Second type of chemical properties of bases is neutralization reaction. You know that when bases react with acid or acid react with bases, it will form salt and water by neutralization reaction. Huh. So bases or alkalis such as calcium hydroxide, sodium hydroxide, potassium hydroxide, when any bases react with any acid, it will form salt and water by neutralization reaction. For example, when calcium hydroxide, CaOH whole twice, react with HCl, that is CaOH whole twice plus 2HCl, it will form a salt which is calcium chloride, that is CaCl2 plus 2H2O. Okay, this is actually a double decomposition reaction. Similarly, when FeOH whole twice, that is ferrous hydroxide, which is also a base, when react with acid, which reacts with an acid, that is HCl, that is FeOH whole twice plus 2HCl implies FeCl2, which is salt plus 2H2. Okay. And third chemical properties of acid, yeah, of bases, I have told this one in the preparation of some bases from a from a base by double decomposition reaction. I have told that this one. These are the chemical reaction of bases also. Okay, so when third important chemical properties of bases are they precipitate as insoluble metallic hydroxide when added to a solution, aqueous solution of some salt like copper sulfate, zinc sulfate, ferrous sulfate, ferric chloride, aluminum chloride. Okay, so when bases react with metallic salt, that is CuSO4, ZnSO4, it will form salt and insoluble hydroxide, that is insoluble product will form, that is precipitate will form. For example, when copper sulfate, aqueous solution of copper sulfate, CuSO4, when react with ammonium hydroxide, that is NH4OH, so CuSO4 plus 2NH4OH, it will form ammonium sulfate. Aqueous solution of ammonium sulfate formula is NH4 whole twice SO4 and a pale blue precipitate of copper hydroxide. The color of copper sulfate solution is blue, but when it react with ammonium hydroxide, it will form a pale blue precipitate of copper hydroxide. I have told the chemical reactions also. Similarly, when zinc sulfate, ZnSO4, react with sodium hydroxide, that is plus 2NOH, it will form sodium sulfate Na2SO4 plus a gelatinous white precipitate of zinc hydroxide, ZnOH whole twice. Gelatinous white precipitate. You have to remember the color of precipitate also. Okay, these are important reaction I have marked. And when similarly when ferrous sulfate ApSO4, aqueous solution of ferrous sulfate, reacts with sodium hydroxide, it will form sodium sulfate, so aqueous solution of sodium sulfate, that is Na2SO4 plus a dirty green precipitate of ferrous hydroxide FeOH whole twice, that is FeSO4 plus 2NOH implies Na2SO4 plus FeOH whole twice, and the color of dirty green FeOH whole twice precipitate is dirty green. Here one point, one note has given, you have to remember that the hydroxide of some metal like zinc, aluminum, lead, they are amphoteric in nature. That's why they dissolve in excess alkalis, that is in excess base, that is NOH, KOH. Okay, but the other hydroxide do not. that is copper hydroxide, ferrous hydroxide. This hydroxide will not dissolve in excess alkalis. Okay, but zinc hydroxide, aluminum hydroxide, this precipitate of these hydroxides will dissolve in excess NOH or excess KOH. For example, when zinc hydroxide ZnOH whole twice reacts with excess NOH, the gelatinous white precipitate of zinc hydroxide will dissolve. It will form sodium zincate, that is Na2ZnO2 plus water molecule, that is plus 2H2. Okay. Now fourth chemical and last chemical properties of bases is when alkalis are warmed with an ammonium salt, a ammonia gas is given out. So ammonium salt when reacts with alkalis on heating, it will form salt, water and ammonia gas. For example, when ammonium chloride react with sodium hydroxide, that is NH4Cl plus NOH, it will form NaCl plus water plus ammonia gas. Similarly, when NH4Cl plus calcium hydroxide, that is COH whole twice, on heating it will produce calcium chloride plus water plus ammonia, that is CaCl2 plus 2H2O plus 2NH3 gas. Okay. Similarly, when ammonium sulfate react with KOH, that is plus 2 KOH, implies K2SO4 plus water, that is H2O plus NH3. Okay, you have to remember all the chemical reactions. These are especially uh, point number 3, point number 4. Okay, these are and point number 1, and all these are very important chemical reactions of bases. You have to remember. Okay, thank you.